Lesson 12, Solved Problems, Part 2. Example 28. If the sum of vectors A and B and their difference are perpendicular, show that magnitude of vector A is equal to magnitude of vector B. Solution: if the sum and difference of the two vectors are perpendicular to each other, then their dot product is equal to 0. When you expand, you have this result. You need to note this: the dot product of two vectors is commutative, and when you add these two terms, it is equal to 0. Hence, we are left with this minus this in this form. The dot product of a vector by itself is equal to square of the magnitude of the vector. We transfer this term to the right hand side, it becomes positive. Equating the powers, we have the magnitude of vector A equal to magnitude of vector B. Example 29. Prove vectorially that the diagonals of a rhombus are perpendicular to each other. Solution: this diagram is a rhombus. We wish to show that AC is perpendicular to BD. Let vector AB equal to vector DC equal to A, and vector BC equal to vector AD equal to vector B. Vector AC is equal to vector A plus vector B, which is the same as vector A as vector B plus vector A. Vector BD is equal to vector B minus vector A. For the rhombus, vector B is equal to vector A. For us to continue, we have to take the magnitude of the two vectors and square it. To proceed, you transfer this term to the left hand side, it becomes negative, and you equate the expression to 0. Remember that the dot product of a vector by itself is square of the magnitude of that vector. So this term is equal to this, and this term is equal to this. For us to continue, we need to add these two terms. This expression is equal to 0, but we need to add it in order to continue with the solution. Next thing, we group the first two terms as 1 plus the last two terms. You factor out the common term respectively. From here, the sum of the two vectors is here. Then you have vector B minus vector A is here. The difference is perpendicular to the sum of the two vectors. It is so because their dot product is equal to 0. Remember, we said that two vectors are perpendicular if their dot product is equal to 0. We have achieved that. Hence, AC is perpendicular to BD. Example 30. Show that vectors U, V, and W are mutually perpendicular, and find the unit vectors for vectors U, V, and W in the direction of U, V, and W respectively. Solution: you have the three given vectors. Vectors U and V, U and W, pairing the first with the second and the first with the third, are perpendicular if the dot product of vectors U and V is equal to 0, and the dot product of vector U and W is equal to 0. So we find the dot product of vectors U and V. When you do that, you have it in this form and you have 0. Remember, first component times first component plus second times second plus third times third. You have 0. So vectors U and V are perpendicular because their dot product is equal to 0. For vectors U and W, when you compute their dot product, you also have 0. Therefore, vectors U and V are perpendicular. Vectors U and W are perpendicular. Hence, the three vectors are mutually perpendicular to each other. Unit vector of U is equal to vector U over the magnitude of vector U over the magnitude of vector U. So you get the magnitude of vector U in this form, and that is 7. So the unit vector of vector U is equal to this. For vector V, you have the unit vector to be equal to this. You get the magnitude of vector V, which is equal to 7. This becomes the unit vector. For vector W, this is the unit vector. You get the magnitude of vector W, that is equal to 7, and you have this as the unit vector. Example 31. Three vectors A, B, C are mutually perpendicular with magnitude of vector B equal to 1 and magnitude of vector C equal to root 2. If the vectors P equal to this and Q equal to this are perpendicular, Roman figure 1, find the magnitude of vector A. Roman figure 2, determine the magnitude of vector Q. Roman figure 3, calculate the magnitude of the projection of the vector P on the vector A. Solution: if the vectors A, B, and C are mutually perpendicular, then the dot product of A and B equal to A and C equal to B and C, it is equal to 0. For us to get the magnitude of vector A, we have to find the dot product of vectors P and Q since they are perpendicular. This is the dot product. When you simplify by expansion, you have these results. Remember that the dot product of a vector by itself is the square of the magnitude of that vector. But magnitude of vector B is equal to 1 and magnitude of vector C is equal to root 2. We need to square them for us to have this part of the solution. So if you square both sides here, you have this result. If you square both sides here, you have this result. So we come back here, which is this, and you replace the magnitude of vector B square by 1 and that of C square by 2, and you have this result. Since P and Q are perpendicular, their dot product is equal to 0. So you equate this result to 0, transfer minus 18 to the right hand side, divide through by 2 to get the magnitude of vector A. Take the square root of both sides and you have it to be 3. Roman figure 2. In order to find vector Q, you need to note that the dot product of vector Q by itself is equal to square of the magnitude of vector Q. So let's compute the dot product. When you multiply, you have this result. The dot product of vector A by itself is equal to square of the magnitude of vector A. The same thing applies to B and C. The magnitude of vector A is 3. When you square it, you have 9. This is for the magnitude of vector B square and that of vector C square. When you simplify and add, you have 31. You equate 31 to the square of the magnitude of vector Q. You have it in this form. To get vector Q, take the square root of both sides, and vector Q is equal to square root of 31. Roman figure 3, let M be the magnitude of the projection of the vector P on the vector A. Then M is equal to the dot product of vector P and the unit vector A. This is vector P times the other term. When you multiply, you have this result. The unit vector A is expressed in this form. You have it here, you have it here. Vector A dot vector A is square of the magnitude of vector A. You have the second term, you multiply, and the third term. Note that B dot A is equal to 0. C dot A is also equal to 0. If you replace this term with 0, this term with 0, you have this result. So everything here becomes 0. You are left with this. When you simplify this term, you have 2 times the magnitude of vector A, which is 3. So you have 2 times 3 equal to 6. End of lesson 12. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.